All right, we are looking at 7.1 probability notes. Now, when we're looking at probability, we're looking at how many times we can, like, what's the probability of something happening? What's the likelihood of something happening? So let's take this spinner, for example. We have the spinner right over here. Got the spinner. You're going to spin this thing 100 times. Now, you're like me, you could say, hey, you could spin that thing 100 times and you could get C every single time. You could get an M every single time. You get a W every single time. Now, however, when we're talking about probability means like, what is the likelihood of something happening? And because the W takes up 50% of that square, or the circle, I'll call it a square. 50% of that circle, we can say, hey, if we did that 100 times, W is going to show up about 50 times or 50 times. We can just say that, okay? The M, this would be like, what, 1/4, which would be 25. Looks like maybe another 10. So the M would show up about 35 times, leaving us with 15 for C. That's probability. So as we go through some problems here, just a couple samples, that's kind of what we're talking about. We're talking about mathematical probabilities of this happening or that happening. That's why when you see a news report and they say we have a 50% chance of snow, or a 10% chance of snow, or a 90% chance of snow, those are different things happening. Those are different. Like if someone says, hey, there's a likelihood of this happening 10% tomorrow, don't bet your life that's going to happen. You know what I mean? But if something's 90%, that's still not 100%, but hey, 90% chance this is going to happen. It's probably happening. So that just kind of gets us into probability. Here we go for some more. All right, so let's even take a look at the next one. So here we have a spinner. You spin this spinner. How many possible outcomes are there? How many things are there? 1, 2, 3, 4, 5. There's 6 different things that they can land on, right? So how many possible outcomes are there? Okay. So let's see, the possible outcomes of spinning a 1, a 2, a 1, a 3, a 1, or a 4, there's 6 possible outcomes. All those things could happen, right? The purple 2, there's a red 1, there's another red 1, there's a 3 blue, and so on. So 6 possible things. So what are the favorable outcomes of spinning an even number? What does that mean? A favorable outcome? Like, okay, let's think about that. What are the odds that a likely event that you're going to spin, it's going to be an even? Well, how many even numbers do we have? We have a 2 and we have a 4. We have 2 out of how many total? Well, the other 4 numbers are odd. So we have a 2 out of 6 that you're going to spin an even number, right? So there's our evens, there's our not even. So we have a 2 and we have a 4 to get that. So our favorable outcome is 2 out of 6, right? 2 even out of 6 possible. The favorable outcomes of spinning an even number are 2 and we have 4, right? 2 and 4. Because our 1, our 3, and a 1 are not even. And how many ways can spinning a number less than 2 occur? Geez, can we get less than 2? Well, how many times can we get less than 2? Easy peasy, right? Those are all our times that we can spin. So we're going to have a 2, a 1, and a 1. So that's kind of like just an intro to kind of how this goes. We'll keep going with some examples. All right, before we get too far into it, we're going to use words in this chapter like impossible, or that's kind of unlikely. Well, that's kind of just as equally likely to happen or not to happen. That's 50-50, right? Hear those phrases a lot. Or, that's pretty likely that's going to happen. Or, this is certain it's going to happen. Certain, okay? It's kind of like I'm in a classroom right now. It's 2:23 p.m. It is certain that it's going to be 2:24 in 30 seconds. So, like, there's things that we can say that are certain, and then we can things that are like impossible. Say, hey, I'm going to clap my hands together, and I'm going to say like abracadabra this or that, and it's going to go back 1 hour in time. Can we say that's unlikely, or is that 50-50, or is that impossible? That's impossible, right? That does not happen. So now we get a quick example on the rain thing we talked about. There's an 80% chance of rain, a 50% chance of thunderstorms, and a 15% chance of hail tomorrow. So let's describe the likelihood of each event. Just that there's rain tomorrow. What is the likelihood of it just raining? 80%, right? So this is what we're talking about. Hey, there's an 80% chance of rain. So if we had a picnic scheduled for tomorrow, it would probably, pretend it's the spring or summer, we should probably make other plans, either reschedule the picnic or just the picnic have a shelter, because there's an 80% chance of it. But because also, well, so let's just take that example. So because there's a 50% chance for a thunderstorm, I don't even just want to be, like, say I'm at a park with an outdoor little shelter. That's not protecting me very well from a thunderstorm, even hail. So if I'm not inside somewhere having this party, we're gonna be in trouble, because the probability is 50% thunderstorms are equally likely to happen or not happen, but that's pretty high, especially when we know it's really likely it's going to rain, so there's an 80% chance. And then you think, like, hail, do we even want to be out and about? Do your parents want to come because they're driving in this and they could hail damage on their car, right? We want to make sure we're in the garage if possible, or or covered. So making plans, we tend to look at those things. Is it going to snow? Is it going to rain? How's it going to affect our driving conditions? We use probability. I mean, we use probability all the time, even if we don't realize it. All right, so here's like a definition that would be good for you to write in your notes. So you're going to want to pause this and write this down. When you conduct an experiment, the relative frequency of an event is the fraction or percent of the time that the event occurs. So relatively frequency equals the number of times the event occurs divided by what? The total numbers of time you conduct the experiment. So I'm going to continue with the video. You pause it, you write that down, so you have that for when you're doing examples in a few minutes. But we're going to do one of those examples right now, okay? So this is something I see people doing in class all the time. Not all the time, but sometimes. You flip a bottle. You record the number of times it lands upright, the number of times it lands on its side, and then you describe the likelihood that the bottle lands upright on your next flip. So here's what you did. Here's what happened. You've already done it 5, 10, 15, 20, 25 times. You have nailed it. It has stood up perfectly, just like it shows in the picture on the table. You've done that twice out of 25. Okay? We've done that twice out of 25. So you've landed it 2 out of 25. So how do we do that? The total number of times the event occurs divided by the total number of times that you conducted the experiment. So the number of times we landed it was how many? 2. So 2 divided by out of how many times we flipped it? Not 23 times, we flipped it 25 times. So 2 out of 25. So just like you see here, 2 divided by 25. Landed it 2 times. It was flipped 25 times. The relative frequency is 2 out of 25. If I ask you to convert that to a percent, what percent is that? It's an 8% chance. So you have to ask yourself, so if your buddy's sitting next to you right now, like, hey, you're going to flip that thing. I know you've landed it 2 times. I know you missed 23 times. You have an 8% chance of getting it on the next try. Like, if I'm your buddy, I'm like, hey, you just won a sucker from the teacher. I bet you a sucker that you don't get it on this next try. And if you take that bet and you flip it and you lose, you look silly, because really, mathematically, your friend knew you only had an 8% chance of getting that right. You're probably not. Now, you could flip and get it. Now, all of a sudden, it's 3 out of 26, and that changes. But the odds are, since it's only 8% because you haven't done that well, and that's all sports guys do. If you follow basketball, you follow baseball, you follow football. If you have a kicker in the NFL and he's made 5 kicks out of his last 20, the odds are the coach on 4th and 4, and it's a 40-yard field goal, they're going to say, you know what? Because of the analytics, because of the math, we're not going to kick the field goal here. I would like to get the 3 points, but we're going to go for it on 4th down because of the relative frequency that our kicker makes or doesn't make field goals. All right, what I want you to do here is I want you to answer these 4 questions before we're done with the video. So you're going to see the spinner on the right, and you're going to see how many possible outcomes that there are. You're going to write that number right there. I want you to see what are the favorable outcomes of spinning a number no greater than 3. In how many ways can spinning an even number even occur? You're going to have an answer for that. And it's going to be something out of a total every time, right? Like a fraction. So in how many ways can spinning a prime number occur? So what you're going to do is, I'm not going to put the answers here in this video. What you're going to do is, when you show me your notes for 7.1, you are going to not only show me your notes, but then you're going to show me these 4 questions, and you could label them 1, 2, 3, 4, or 14, 15, 16, and 17. Yeah, maybe just do 14, 15, 16, and 17 so there's no confusion. You'll come back and say, hey, I have those answers I want to show you. Some people won't even watch the video and they won't do it and they won't get the points, but you are watching it, you're doing what you're supposed to do, and you're going to get the points. So answer these 4 questions. That will wrap up the video. So make sure, I'm going to shut it off. You're going to pause it, keep it right here so you can finish it. All right, guys, see you later.